So in today's lesson, we're going to be looking at direct variation, which is also often called direct proportion. And we're going to look at what it is, conditions that it needs, constants of variation, or what's called the constant of variation, and common mistakes people make with direct variation questions. Because this is what we're going to be playing around with next lesson. So firstly, what is direct variation? Now it sounds quite fancy, but we've already been doing it in linear relationships a lot of the time. So what direct variation means is that as our x variable changes, the y variable changes at the same ratio. And in linear relationships, we call this the gradient. In direct variation, we call it the constant of variation. And it just looks like this. So this is an example here. So let's this is straight out of math space. So Oliver is making cups of the fruit smoothie. The amount of bananas and strawberries he uses is shown in the proportion table below. Now they've given us their independent variable and their dependent variable that we just looked at earlier. So we've got our x and our y, and they're saying as the strawberries increase, we have to increase the bananas as well. And the relationship that takes place becomes this straight line here. Now see that we have a constant gradient here, so we don't have a line that curves all over the place. We have a constant straight line, so we have the same ratio between each strawberry to banana combination, like this, which results in this straight line. And this is a direct variation relationship or a direct proportion relationship. So we've got a straight line. Now there are a few conditions for you to be able to call it a variation, a direct variation. It can't just be any straight line like that we were doing in linear relationships. The first thing is that it must pass through the origin. So that's what we've got here, passes through the origin. So we have to start at 0. When x is 0, y has to be 0. So if we don't have any strawberries, we don't have any bananas, we can't make the smoothie. It has to pass through the origin, has to be a straight line, and it has to have a constant gradient. They're the three conditions that must be met. We have to have this constant of variation, or what we call k, and we can just figure that out now with this example here. So when we had linear relationships, we would write it as, we'd write like y, oh, there we go. I'm just going to change that to a little bit narrower there. Y equals mx plus b. That was our thing. And that plus b was our y-axis intercept, so where it cut that y-axis. We can't have that plus b in our direct variation line. It has to go through the origin. So we're going to get rid of that plus b. That's not going to exist. We're only going to have the mx factor. But instead of, just to differentiate between the two, just a regular linear line and a direct variation, we actually now call it the constant of variation instead of m. So we're going to now our relationship we write as y equals kx. And k being our constant, it's the fancy word that we call constant variation. And we can find their k. So in our situation here, we can just substitute the two terms that we know in, and we'll just pick two relevant terms. So we can start with any of these that we would like. It might be easier just to start with this 1611 because we don't have any decimals involved in that one. So we're just going to substitute into our bananas. They've given us as our y variable here. So bananas are 11 equals k times strawberries is 16. K times 16. And we know how to rearrange that equation to get k on its own. So instead of k times 16, we're just going to divide 3 by 16 on both sides. Divide by 16 over here, divide by 16 over here, and we're left with k is equal to 11 over 16. And that's what our k is. So if we wanted to write, now we could find the decimal that is, but we can just leave it as 11 over 16 for the purposes of this. So our equation of our smoothie is going to be y equals 11 over 16 times x. And sometimes you'll end up with a lovely integer there, sometimes it'll be a fraction. But as long as you're saying that in order to get from y to x, you have to multiply x by this 11 over 16. Last lesson we looked at the oranges problem where we had y, so the amount of that you would have to pay would be equal to 3.5 times the amount of oranges, which we were calling x. So that was for every kilo of oranges, you had to pay $3.50. So the amount of money you'd have to pay was 3.5 times the oranges. That was the example we looked at last lesson. This is an example of direct variation because we go through the origin, we have a straight line, and no matter where we are on that line, that gradient or that constant of variation is always the same, 11 over 16, which results in our straight line. Sometimes you'll get asked to write a statement of proportion, or sometimes you'll see a question and they'll say something like the price of fuel is directly proportional to the litres that you buy, or something like that. So it's often worded different ways, but it's the same thing. Y is directly proportional to x, y is proportional to x, or y varies directly as x. And it's those key terms that you're looking at, directly and proportional. And if you've got directly or proportional in there, you're probably looking at a direct variation question. So there's our statements of proportionality, and they just mean the same thing. They just mean that y is proportional to x. And this is our funny symbol. Looks like a weird little fish here. And in type, like if you're not handwriting it, looks like this little thing here. So y is proportional to x. That's just our Greek symbol there. Y is proportional to x. And we write it that. So we can either write y is proportional to x, or we can write it in equation form. Y equals k, so some constant, times x in each situation. I might just look at some common mistakes that people make before we do a quick example. So assuming k must be positive, so 99% of the time you'll get a question where you have, so just getting that out of the way, you'll get a question where k is positive. So if you had a axis, most of the time you would have a straight line. Whatever gradient it is at would be a straight line. I can actually even put a gradient in there. Or you could have like lower down here or out there. Most of the time it will be a positive one. But in theory, you could have a negative k, and as long as it's going through the origin, that is still a proportional relationship. You usually won't get that type of thing, but in theory you could have y is equal to negative kx. That can happen. So that's one mistake people make, mixing up with which variable is k and which variable is x. So you might have a question that says the amount of puddles is proportional to the rain in the rain gauge measure, the milliliters in the rain gauge. And if you mix up which one is proportional to which, then you'll end up with the wrong k value. So for example, if this one, they gave us bananas as our y-axis and strawberries as our x-axis. So if we accidentally switch those around, we would have a different value for k because we would have had 16 over 11. So it is important that you put your dependent variable on the y-axis and your independent variable on the x-axis, or you'll end up with a different k value. And if you in a situation like this one where it's not obvious which one is dependent on the other, they will usually give it to you. And then lastly is forgetting the conditions. So you're forgetting that it has to be a straight line and it has to go through the origin and it has to have a constant gradient, which happens if it is a straight line anyway. That's direct variation in a nutshell, and we're going to look at some examples in class.